You know what helps us communicate really, really well is when we have a common framework or a common reference. And even though today we're using a lot of these bad boys, multi-layer switches, which have layer 2 switching capabilities, they do access ports and VLANs and trunking and all the rest, and they have the ability to do routing in between those VLANs with logical SVIs, switched virtual interfaces. So why in the world then, in our network diagrams, do we still show hockey pucks or routers even though we're using multi-layer switches? So my objective for you and I in this video is to give you an insight to help bridge the gap between logical topology diagrams and the actual physical gear that's actually moving the frames and the packets. And I think it'd be very helpful if we use this network topology right here that we used in our previous video as we predicted the layer 2 and layer 3 addresses as a packet and frame made their way across the network. So in this topology, we have 2 routers, 3 separate networks, but the reality is this type of network usually is going to be implemented on a multi-layer switch. So from a physical perspective, it's more likely to look something like this. And we might ask, well, how is this network down here? I mean, it's kind of a shock factor. How is it like this one? Well, let me draw out this network topology in the same type of layout here. So we'll start off on the left with our user Bob. So there's Bob, the happy user, with his PC. And his PC is right here in this topology, sitting in VLAN 10. That's because it's on an access port that's associated with VLAN 10, and boom, that's where Bob is. And Bob's IP address is 10.16.0.10 with a 24-bit mask. And Bob has been trained to use a default gateway of 10.16.0.1 on that same network. Now, that default gateway is actually being provided by Core 1. So from a logical perspective, it would look like this. We have Core 1 as a logical router for VLAN 10. And this interface right here would be interface VLAN 10. And it would be given the IP address of 10.16.0.1 with a 24-bit mask. So as we do side-by-side comparison, here's the computer, there's their default gateway. And in this case, that default gateway that Bob's using is available over this layer 2 trunk that goes between the access layer switch and the Core 1 multi-layer switch. Now, as we continue the journey from left to right here, after Core 1, this segment of our network here is actually in VLAN 40. And the network address space here is 10.16.6.0 for VLAN 40. And this router has the IP address of .5, and the multi-layer switch on VLAN 40 has the IP address of .1. And so if we continue to draw this out, this second interface here, interface VLAN 40, in this topology, that logical layer 3 interface, that switched virtual interface on that multi-layer switch would have the layer 3 address of 10.16.6, that's the network, and we could give it the IP address of .1. So this multi-layer switch, Core 1, has 2 logical interfaces, 2 layer 3 interfaces. Interface VLAN 10, interface VLAN 40, both with their respective IP addresses. So the next device in the path would be this router right here, which in our topology here is router 1 AZ. And this interface on router 1 is 0/0. So we put gigabit 0/0 here, and its IP address is .5 on the 10.16.6 network. And so this connection between the router as it connects up to the core switch, it's connected to an access port that's associated with VLAN 40. And that's why this router interface is in that VLAN. And then on the other side of this router, so R1AZ is playing the role of R2 in our earlier topology. On the other side, we have the 192.168.1.0 network with the 24-bit mask. And in this topology, that interface is 1/0. So on router 1, it's interface 1/0 that goes out to that 192.168.1 network, and its IP address we're using on that interface is .5. So I wanted to take a moment and step back and share with you why we still use the hockey puck icon in our topology diagrams, is so that we can describe or talk about the logical function of how data is forwarded. So in our topology, this is an icon for a layer 2 switch, Core 1, and this icon is an icon for a multi-layer switch. So I'm going to use 2 colors there. One color representing layer 2 and another color representing layer 3. And down here, router 1 AZ, the hockey puck icon is the icon for a layer 3 router. And the reason I bring this up and show the comparison side by side is because this is what I wish someone had done for me a couple decades ago when I was first learning about multi-layer switches. It just showed me a side-by-side comparison. Okay, oh, here's how we view it logically with the router icons, but here's how we implement it, and here's the physical connections in a multi-layer switch. So I thought, let's take one additional step here, and let's go to a lab. Just click on the link for the virtual lab if you're logged on to CBT Nuggets, and let's take a look at a few interfaces on the multi-layer switch and on the router, just so you can reinforce these concepts that we've just looked at. So when you bring up the lab, it's going to default you to this computer called DCNUG. This is our management PC, and I've got MT PuTTY, which is multiple tab PuTTY, already running. So if we just want to look at these four devices, the access layer switch, Core 1, Core 2, and Router 1, these tabs are already present for us. So let's begin on Core 1. And Core 1, if we want to look at the layer 3 interfaces, we can do a show IP interface brief. And so here we have these two interfaces that I want to point out, which is the interface VLAN 10 with this IP address and interface VLAN 40 with the 10.16.6.1 address. So these are the two logical layer 3 interfaces that we just drew out on the topology a few moments ago. And if we take a look at Router 1, and on Router 1, we do a show IP interface brief and press enter. Here's its gig 00 interface. Now, physically, this interface is connected into an access port on VLAN 40 on the core switch. And so this interface has an IP address associated with VLAN 40, which is the 10.16.6 network, with a 24-bit mask. And then the interface off to the right in our topologies that we've been drawing so far, it has the IP address of 192.168.1 with a host address of .5. And I think it's time for me to come clean with the dirty little secret that I have, and that's this. You know, some of the packet captures that we've been enjoying up to this point in this skill, those packet captures, even though I showed a simple topology with router, those were actually captured using the multi-layer switched environment as part of this lab. So the benefit is that the logic is the same. The layer 2 address information, the way layer 3 works, the routing, the forwarding, all that works the same regardless of how we're physically implementing a solution. And that's why I wanted to talk with you about the logical versus physical implementations and why we still draw hockey pucks even if we're using multi-layer switches, is to represent that we're doing routing between networks. So I'd like to do one more thing, and that's this. In the lab environment, let's go to the client PC. And you can get there in the lab environment on the right. You can click on the link for the client PC. And let's open up a browser from the client, which is Bob's computer, to 192.168.1.100 and verify that that works. And once it does, all the traffic that we've seen up to this point, all the packet captures that we've seen, the layer 2 and layer 3 address information, that was all generated as a result of this client making a web request over the network. So over on the right-hand side in the lab environment, if you click on the client PC, all we need to do is open up a browser. I'm just going to go ahead and click on Chrome. It's on the desktop. And let's go to the IP address of 192.168.1.100. And hold on to your hats, because all that traffic, all those captures that we saw in the background in the previous videos, those are all generated as a result of this one request. So we'll press enter, and there it is, bringing up an IIS service. It's a Windows server on the back end at .100. And I'm excited to share with you how much fun I've been having in putting all of this together. I mean, I've got a lot of years of experience in working with this, and it's fun to break it apart and put it into small pieces that are fun and enjoyable to consume, including labs. So regarding labs, these labs that we're doing in the virtual environment, they're not made or intended to do everything an enterprise network would ever want to do at any moment, but they are highly focused to give you the ability to do the task at hand and the show commands at hand, so you can get that hands-on practice with it. I also wanted to share with you as a heads up that in this lab we're focused on show commands and configuration commands, but a few commands have been restricted, like show run or show start, because I wanted to focus on, like in a real world, if we're in user mode and we're doing show commands, I want us to get a feel for those commands and just have them just be right at the tip of our tongue and be able to implement those. And we can get to that point through practice, practice, practice. So I would encourage you every time together that we have a virtual lab, and I ask you to click on the virtual link or the link for the virtual lab, to go ahead and make time to do it. So if you're watching this on a mobile device, which I often do, instead of a computer, just schedule maybe 20 or 30 minutes a week to log into CBT Nuggets on a computer and actually do the hands-on practice along with me in the labs. Also, if you haven't already done so, I make sure that you're aware of Packet Tracer, which is a great option. We've got some videos here on Packet Tracer, how to get up and running with that. Or if you're using Viral, that's another great option. Or if you have physical gear, no matter how you do it, I would encourage you to do the hands-on practice. And I have some exciting labs that are coming up for us that you are going to enjoy as well. So I'll see you in those future videos. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.